section 7.7, part 1 of 3, and we're going to be talking about composition of functions for the next 3 lessons, okay? So to start off, I want us to bring our brains back to what happened in section 1. Okay, section 1 we had problems like this, where we were asked to find f of 2a if f of x equaled x squared minus 6x plus 1. Okay, what you need to recall here is that here if you see your x is being replaced by this 2a, then all that you would do is replace these x's with the 2a as well. So now we have 2a squared minus 6 2a, okay? And then we simplify, so you square the 2, square the a, multiply through here and add, and then you get your final answer. Okay, we're going to be doing that today, except now we're going to be doing it with entire functions instead of just letters. Alright? So, the composition of functions, if f and g are functions such that the range of g is a subset of the domain of f, then the composite function of f and g is f of, this is a little circle, it looks like fog, but it's actually a little circle, this is our composite symbol, f of g of x equals f of g of x. Okay? Make sure that you have this written down. We're going to go into more depth on domain and range tomorrow. Today what we're going to focus on is how we can actually set up these problems. Okay? So make sure you have this definition written down, and then we will go on to a couple examples. So, here, if f of x equals x plus 3 and g of x equals x squared plus x minus 1, our first goal is to find f of g. Now our definition said that f of g, I'm going to be going back and forth between colors to help, says that this is f of g of x. Okay? Now I want you to see this as one big f of x. We know that f of x means that we have a function of x. Okay, so if you look at what is being replaced here, what we're putting in the spot of x, we're actually putting in the entire g of x for x. Okay, so f is our main function, but we're evaluating f at g of x. Okay, so if I'm looking for f of g of x, okay, that means that my base function is f, and I have replaced the x with a g of x. So I'm going to have, wherever I have an x, I'm going to put a g of x. So here in f of x, I have an x here, so I'm going to have g of x plus 3. Okay, you see that? We're taking our function f, and wherever x is, there's actually a g of x there now. So now I replace this x with a g of x. Okay, but we actually have something that g of x equals. G of x equals x squared plus x minus 1. And then we have the rest of our f of x function right here. Okay, so this is my g of x. Okay, so again, here f of g of x, I'm evaluating the function f at g of x. Okay, so wherever my x is, g of x is now. So if f of x is x plus 3, f of g of x is now g of x plus 3. Okay, and my g of x is this whole function from right there, plus 3. Okay, and then we just simplify. We can combine those two. So f of g of x equals x squared plus x plus 2. Okay? Now what we're going to do is we're going to take g of f. Okay, so g of f is g of f of x. So my main function is g, and I'm evaluating g at f of x. So I have g at f of x. Okay? So wherever I see an x in my g of x, I'm going to replace it with an f of x. So here I'm going to have f of x squared plus f of x minus 1. Okay, so wherever I saw an x, I put an f of x. Okay? So my f of x is x plus 3. So I'm going to have x plus 3 squared is x plus 3, minus 1. Okay, this one requires a little bit more work because we have something being squared. Okay, but I don't want you to forget the steps that we're taking. So here, g of f, we're evaluating g at f of x. So wherever I see an x up here in my g of x, I'm putting in an f of x. Okay, so right now I have x plus 3, which is my f of x, squared, plus f of x, which is this, minus 1. Okay, here what I'm going to have to do is I'm going to have to FOIL, or distribute. So I'm going to get x squared, 3x, and 9, which if I combine those, this is going to give me x squared plus 6x plus 9. And then I'm going to have plus this x, and if I combine those two, I get plus 2. Okay? Other terms that I can combine, I have this 6x and this x. So after I combine those two terms, and I have this 9 and this 2 that I can combine. Okay, so after I do that, my final answer is going to be x squared. 6x plus x is 7x. 9 plus 2 is 11. So g of f of x is x squared plus 7x plus 11. Does f of g of x equal g of f of x? No, they don't. They're not interchangeable like that. Okay? That is how to find composite functions, and we will build off this the next two lessons.